So what would be our first step on a problem like this? Well, first it depends on what method we're going to use. If we're going to use the dosage calculation formula, we start out with the order, we just plug into the formula, but on this problem we'd have to go through about 3 steps to do that. 3 different generations of the formula to do that. Similar, this could be solved with proportions. I'm going to go ahead and I'm going to use the dimensional analysis or the unit conversions to do it. And to do that, I always start out with the doctor's orders. The order is, in this case, it's in a rate. Now, a lot of times doctor's orders will just be an amount, and if that's the case, we make it a fraction by putting it over 1. But when it's a rate, it already is in a form of a fraction for us. So 200,000 units over 4 hours. Now, the next thing, I need to somehow get to drops per minute. So I have to get rid of both the units and the hours. I'm looking here, probably going to get rid of the units first. I have this 50,000 units in 1 gram. So I'll put the 50,000 units on bottom. 1 gram would go on top. Now, if I wanted to, I could save myself some time here. Everything else in this problem is not given in grams. It is given in milligrams. 1 gram is how many milligrams? Anybody? Milli means 1,000, right? So milli means 1,000. So 1 gram is 1,000 milligrams. So if I wanted to save some time, instead of putting 1 gram here, I could put in 1,000 milligrams. That'll save me 1 step in my conversion. So 50,000 units in 1 gram is the same as saying 50,000 units in 1,000 milligrams. So now the units cancel out for us. And I'll leave it up to your preference whether you keep stringing this out or if you calculate it and start with a new fraction. It doesn't really matter. I'm going to just keep going here. Next, I'm going to get rid of milligrams. I have this 2 milligrams to 5 milliliters. So the milligrams are on top here. They have to go on bottom here. So 2 milligrams to 5 milliliters. So now the milligrams have cross-canceled out. So what I have right now is milliliters over hours. I want drops over minutes. Well, my next step here, I can change drops into, or milliliters into drops. I have that relationship, 20 drops per 1 milliliter. So my next fraction, I'm going to put the milliliters are on top, so I'll put milliliters on bottom, going into drops. 20 drops per milliliter, 20 drops per 1 milliliter. So the milliliters are gone. So now I do have drops as my top unit, which is what I need in my answer. I need the bottom unit to be minutes. Currently it is hours. So I'll put hours on top going into minutes, and 1 hour is 60 minutes. So my hours cross cancel, and on top, well, what I would do personally, is I'd cancel some zeros before I start punching this into the calculator. Like here, I cancel this 0 and this 0. I cancel 3 zeros here and 3 zeros here. So now it's a little bit simpler for me to work with. So as I multiply this out, I have 200,000 times 5 is 1,000,000 times 2 is 2,000,000. And that's in drops. Over 4 times 50 is 200. Times 2 is 400. Times 1 is still 400. Times 6 is 2,400 minutes. And now it's just a matter of dividing that out. 2,000,000 divided by 2,400 minutes gives me 833.33 drops per minute. And again, we said for now, we're going to round to a couple decimal places on drops. If you're in the ADN program, it all depends on what type of device is used to infuse. If it's a manual, you got to set a drip manually, then you're going to have to go to the nearest round to the nearest drop. If you're using an infuser, you can go to the nearest tenth of a drop per minute. We're not going to get into that. We'll leave that up to whatever equipment you get trained on. Now, obviously, 833 drops per minute is a little high, so one of my numbers was a little funky there, but that's okay. Any questions? Okay. Well, we're going to have next week, of course, is our unit test, so we're going to get some time to review, but there's a couple of topics we have left to finish off. We left off last time talking about dosages based on weight. Which is a little bit of a misnomer because in the metric system we tend to use mass instead of weight, so it's a dosage based on mass, but we'll go with it. So we're looking at the orders are to give recommended dose. So what that means is whatever the label, whatever the medication's recommendation is, that's what we are to give to the patient. So our label says 0.8 milligrams per kilogram per day. And our patient walks in the door weighing 88 pounds. So to start these problems, first step is always to make sure we are talking in the same units. This dosage is given in milligrams per kilogram, but our patient is given in pounds. First step then is to convert the pounds to kilograms. How do we do that? To get from pounds into kilograms, we divide by 2.2. There we go. So 88 divided by 2.2 is 40 kilograms for this patient. So our second step then is to find the recommended dose from that mass. And this is where when we're doing dosages based on weight, and in a little bit dosages based on body surface area, we need to use the proportion. So we are given 0.8 milligrams per kilogram, so per 1 kilogram. And we still want to know milligrams per kilogram. All we want to do is we want to change it from 1 kilogram to what the patient is, which is 40 kilograms. So this is where we set up a proportion, and we will cross multiply and divide. 0.8 times 40 is 32. Divided by 1 is still 32. So the recommended dosage for this patient is 32 milligrams of that medication. And we did a few examples of that to end the class last time. But I want to go the next step. What if, of course, the doctor is still saying recommended dose, so I'm not going to bother writing that. But our label is a little more vague. The label says 1.5 milligrams to 2.0 milligrams per kilogram per 8 hours. And this time our patient coming in the door is 121 pounds. First step, as always, is to find the weight in kilograms. So what are we going to do? 121 divided by 2.2 is 55 kilograms. Is that correct? So 55 kilograms is our patient. Next, we're going to find the dosage from the label, but the problem is there's two different, there's a minimum and a maximum, not just a single dosage given, not just a single recommendation. So we can either do two calculations, or we can do something called a titration. Let's do both calculations. Let's start out with the 1.5 milligrams per kilogram, so 1.5 milligrams over 1 kilogram. We want to know how many milligrams that would be for our 55 kilogram patient. If we cross multiply and divide here, 1.5 times 55 is, what, 82.5, I believe, milligrams? Of course, divided by 1, I didn't say that, but it's implied. Is that what you come up with? Okay, perfect. So that is the minimum dose, because we're using the smaller of the two numbers. Now using the larger of the two numbers, let's find the recommended maximum dose. So 2.0 milligrams per 1 kilogram would be how many milligrams for our 55 kilogram patient again? There we go. Cross multiply and divide, and you do get 110. That would be the maximum dose. The alternative would have been, once you find one of the numbers, let's say once we found the 82.5, we could have done something called a titration. Because everything throughout this calculation is going to be proportional. We could take this minimum dose here, 82.5 milligrams, and we could multiply it by a ratio. The 82.5 was the minimum or the maximum? It was the minimum. It was the smaller number. So what we would do is multiply it by, since it was the minimum, we would put the minimum on bottom and the maximum on top. So what does that mean for this problem? For this problem, the minimum was 1.5 milligrams per kilogram, and the maximum was 2.0 milligrams per kilogram. So for this problem, it would be 82.5 milligrams, put it over 1, and multiply by 2.0 over 1.5. If you multiplied that out, we would get the 110 milligrams as the max. So this was the minimum. That's why the minimum had to go on bottom. The top here was the maximum, so that's why it spit out the maximum. So let's add just a little bit of a layer of complexity to this. Let's say we have a recommended dosage of 0.8 milligrams to 1.0 milligrams per kilogram per day. That recommended dosage may be on the label. It may be from a reference at some other reference. But on the label of the bottle, it says the concentration is 2 milligrams per 15 milliliters. So now there's an added level of complexity here. So we need our patient yet. So let's say we have a patient that is 99 pounds. First step is to, whatever we're given a weight in pounds, we convert it to kilograms. So we take 99 divided by 2.2 gives us 45 kilograms. Next, I'm going to use the minimum, the 0.8 milligrams per kilogram. So 0.8 milligrams per 1 kilogram. And I'll put my 45 kilograms on the other side to see how many milligrams that will give us. So 0.8 milligrams times 45 kilograms is, what, 36? Is that right? 36 milligrams? So 36 milligrams is the recommended dosage for this patient, but that's not how much we're going to deliver to the patient because we have to figure out how many milliliters are going to deliver that to the patient. So we take our 36 milligrams over 1 times, we're going to put milligrams on the bottom here, going to milliliters, 2 milligrams and 15 milliliters. So the milligrams cancel out. 36 times 15 is 540 milliliters over 2. That divides out to 270 milliliters. So that patient, you need to deliver 270 milliliters to that patient to give that recommended dosage. Now, the one thing that we haven't included so far is the time frame. We do have to remember this is all per day, so that would be 270 milliliters per day we'd be delivering. That's the minimum because we used the minimum here. So this is the minimum dosage. To find the maximum, we can take that minimum, 270 milliliters, put it over 1, and we're going to multiply by that conversion. Now our minimum and maximum here are 0.8 and 1.0. Which one's going to go on bottom? The 0.8. This was the minimum, so the minimum has to go on bottom here. 1.0 on top. So if you're doing this on a calculator, you're just going to do 270. You're going to multiply by the top number, times 1, divide by the bottom number, divide by 0.8. 337.5 milliliters. That would be your maximum. So for this patient, we're going to deliver anywhere from 270 milliliters to 337.5 milliliters, and that is per day. So that is your range of acceptable dosages for that patient. Any questions? Okay. Well, one of the things that we sometimes have to deal with, or that you might sometimes have to deal with, is double checking a dosage to make sure it's appropriate. So let's say that the doctor's orders are for 300 milliliters of a serum to be administered to a patient. On the label, come on. Never have one of those days. On the label, it says that the concentration is 0.5 milligrams in 10 milliliters. And you look up the recommended dosage for patients is 1.5 milligrams to 2 milligrams, 2.0 milligrams per kilogram per day. The doctor's orders, by the way, was 300 milligrams every 6 hours. Q6D or whatever that abbreviation is. So anyway, we still need to know the patient here. Okay, let's say that we have a patient that is 55 pounds. Tell me where to start. Sure, we're going to divide by 2.2 to make this into kilograms. So 55 divided by 2.2 is 25 kilograms. Very good. Now what? We're still just looking at the dosage based by weight for now. So the recommendation is 1.5 to 2.0 milligrams per kilogram. Which one do we want to use first, the 1.5 or the 2.0? It really doesn't matter, so you guys pick. 2.0? Sure? All right. Sorry, it's one of those days. .0 milligrams. If you want to use the 1.5, we can. I don't. It's fine. Okay. I'm kind of in my own little world this morning. So I had a student like ask me a question 3 times in my first class today before I really caught what he was trying to ask. I don't know why. For some reason, I'm kind of lecturing to myself today. I don't know. It's Friday. Having me every Friday, you guys, you realize you don't get the best of me ever. So anyway, 2.0 times 25 is 50, divided by 1 is still 50. So 50 milligrams. That is 50 milligrams per day that we have to recall here. So we're going to have to do a conversion, however, on that 50 milligrams. We have to convert it because the concentration is 0.5 milligrams in 10 milliliters. So we're going to take that 50 milligrams, and we're going to do the conversion. I'm going to scroll up here a little bit. 0.5 milligrams in 10 milliliters. The milligrams will cross cancel. 50 times 10 is 500 milliliters. Over 0.5, which is, if we divide that out, should give us 1,000 milliliters. Now again, this is 1,000 milliliters per day. Now there is a reason why I chose the 2.0, because both of our other examples, we'd started out with the minimum dosage, and I wanted to use the maximum dosage just so that I could do this. To do the titration here to the 1,000 milliliters, to convert that to how much that would be, this was the maximum, and we're trying to find the minimum. So since this was the max, we put the max on bottom here, which would be the 2.0. On top then would be the 1.5, which is the minimum. Since that is the minimum, it's going to give us the minimum result here. So 1,000 times 1.5 divided by 2.0 is 750 milliliters. So the safe dosage, the safe dose for this medication, for this patient, is 750 milliliters to 1,000 milliliters per day. So the question then comes, is the doctor's order a safe dose? Well, the doctor ordered 300 milliliters every 6 hours. Now we need to convert this to days. Well, 1 day is 24 hours. So the hours will cancel. 300 times 24 is what? 7,200 milliliters over 6 hours. We divide that out. What's 7,200 divided by 6? 1,200 milliliters per, oops, this shouldn't be, that'd be days and stuff down there, not hours. It'd be 1,200 milliliters per day. So the doctor has exceeded the range of the safe dose. I'll leave it up to your programs to teach you what do you do in that case once you've done that. Let's do another example of that. So let's do doctor's orders. 500 milliliters every 8 hours. And let's say that the label states that the concentration is 2 milligrams in 25 milliliters. So what is that? 40 milligrams. And let's say that the recommendation is anywhere from, come on, there we go. Anywhere from 2.0 milligrams to 2.5 milligrams per kilogram per day. And we have a patient that weighs, oh, let's go 132 pounds. First step, as always, is pounds to kilogram. So we divide by 2.2. What's that give us? 60 kilograms. Very good. Then what? Well, we have to pick one, either the 2.0 or the 2.5. Which one are we going to use? I'll actually listen this time, I promise. 2.0, okay. See, she's important enough. I listened to her. Sorry. 2.0 milligrams per 1 kilogram. On the other side, what's going to go in here? Oh, our 60 kilograms from our patient. So we'll cross multiply and divide. 2.0 times 60 is 120. Divide by 1 is still 120. So 120 milligrams. What's next? Convert that to milliliters. Perfect. So 120 milligrams over 1. And over here we're going to do, how do we convert it? Perfect. There's 2 milligrams on bottom, 25 milliliters on top. So the milligrams do cancel out. 120 times 25 is 3,000 milliliters over 2. So that's 1,500 milliliters. But that is 1,500 milliliters per day. Is that the minimum or the maximum? That was the minimum. So to find the maximum, we do our 1,500 milliliters over 1 times, well, the 1,500 came from the 2.0, so the 2.0 goes on bottom. So 2.5 goes on top. So 1,500 times 2.5 divided by 2.0. 1875 milliliters. So what that means is our safe range here is 1,500 milliliters to 1,875 milliliters per day. Now what do we want to do? Check the doctor's orders. The doctor's 500 milliliters every 8 hours. What are we going to do with that? Yeah, we're going to take 500 milliliters every 8 hours. Now, yeah, if you notice that there's 3 8-hour periods in the day, you could just multiply by 3. I'm going to go through the formal conversion just because that's what they pay me for. 1 day is 24 hours. The hours cancel out. 500 times 24 is 12,000 milliliters in 8 days That divides out to be 1,500 milliliters per day. Is that a safe recommendation, a safe order? Yeah, the doctor's order is safe. That's a good question. Again, I'll leave that up to your program instructors to talk about that, but generally you never change a dose without talking to whoever made the dose, because they're technically the only one that can change the dosage. But if it's less than, you'd still probably bring it up to them and ask them, see if they wanted to change it. There may be a reason why they went less. If it's more than, and again, I'll leave it up to you. Sometimes you administer the dose and you ask them if they want you to give more later. If it's more than, obviously you would never administer the dose. You'd talk to them.
Okay, I got a question.
Yeah.
If we're doing formula,
Yeah.
it's stuck in my head here. If I do, like the doctor's orders 500,
Yep.
being that's in milliliters, can I put the 25 milliliters underneath it and times it by 2 milligrams?
Okay, if we're doing the formula, okay, you got the doctor's orders of 500 milliliters.
Yep.
We have to start out with the label on the bottle, which is, what was that, 2 milligrams and 25? So yeah, the 25 milliliters has to go here, and the vehicle would be the 2 milligrams. Okay? So that would be what, 20, that would give us what, 40 milligrams? So the doctor ordered 40 milligrams, is what the doctor just ordered. Then we would compare that to, we would still have to do the proportion. There is no way to take that recommended dosage. I guess you probably could. If you have the 60 kilogram patient, but 1 kilogram is a recommended dosage of 2.0 milligrams. You could do it that way with the formula, which is going to give you the 120 milligrams. But then you got to realize this is per 8 hours and this is per day. And then you could work them that way. But you can see each one of them becomes like each step becomes a separate problem instead of being able to do it all at once. If that's the way it works for you, if that's what it thinks. Well, I mean, the nice thing about the dosage calculation formula is you know that whatever units go on top, you have to put the same units on bottom.
Okay, that's why I was questioning.
Like here, it doesn't make much sense to have 60 kilograms and put the 1 kilogram on bottom. But you have to, because those units have to be the same. And then the 1 kilogram is linked to the 2 milligrams. Although the 2 milligrams really isn't a vehicle, that's where it has to go because it's linked to the 1 kilogram. Yeah. So that's the problem with the dosage calculation formula, is the terminology of the on hand and the vehicle. You don't have 1 kilogram on hand, but that's the relationship, is 1 kilogram to 2 milligrams. Okay. Let's have a doctor who has ordered 1,200 milliliters every 6 hours. A label that reads 3 milligrams and 10 milliliters. So you look up the recommendation, and the recommendation is (3 milligrams to 4 milligrams per kilogram per day. Okay, let's see here. And let's say that you have a patient. Come on. Who comes in at 154 pounds. In your notes, find what the safe range of the dosage is and see if that is a safe dose. So what's our first step going to be? Pounds to kilograms. So 154 divided by 2.2 is 70 kilograms. What's next? Pick which one of the recommended doses we're going to use, the 3 or the 4. Go for it. You did the 3, okay. So 3 milligrams per kilogram equals what on the other side? Milligrams over 70 kilograms. Perfect. So then we'll cross multiply and divide. Set 3 milligrams times 70 kilograms is 210. Divided by 1 is 210 milligrams. So 210 milligrams, what are we going to do with that? Over 1. Okay, perfect. I always do the bottom first because I know that milligrams have to cancel it, but it's the same thing. 10 milliliters per 3 milligrams. So the milligrams cancel. This is 2,100 milliliters over 3, or 700 milliliters. And of course that is per day. Perfect. So that was the minimum. How do we find the maximum? By 4 over 3. Perfect. Which is going to give us 933.33. You got it. So our safe range is 700 milliliters to 933.33 milliliters per day. So the big question, was the doctor's recommendation safe? No, he went over that in one dose, didn't he? And technically, 6 times a day, so times 4, he was recommending 400 milliliters per day. Probably looking at a comatose patient, or worse. Something I should note. I got asked this question in another class here a couple days ago, and it made me think of you. And I'll show you why. Point 8. The question came up, do we need to put the 0 in front of it? And the answer is mathematically, no. I mean, 0.8 is perfectly acceptable. But a lot of decimal points get made like I just did there. Is that a decimal point, or is that just a stray mark? Is that 0.8 or is it 8? It can be kind of unclear. But if I put the 0 in front of it, that highlights the fact that it's a decimal point. There would be no reason for this 0 if that really wasn't a decimal point there. In the ADN program especially, they have started marking things wrong if that 0 is not in front of the decimal point because of that clarity, just to highlight that it's there. So I just wanted to bring that up to you. Okay, we are a touch early, but I think this is a good spot to take our break. So the clock on my computer here says 11:16. The wall here is about a minute and a half slow. So let's start lecture again at 11:26.